Hold on. What time is it? Check my phone. Ah, it's homework time. Let's look at some homework problems. I'm very weird in these videos today. We're going to start with number 10 in the homework. So for the following exercises, graph the function and its reflection about the y-axis on the same axes and give the intercept. Our function is h of x equals 6 times 1.75. That's the word I was going to say. It starts with f. 6 times 1.75 to the negative x. We want this function, and we want its reflection about the y-axis. And the intercept. So you can graph this by hand, or you can graph it with Desmos, but either way, your final answer needs to be on your own paper. Let's start with Desmos. 6 times 1.75 to the negative x. All right, so we got an asymptote at 0, a y-intercept up here. You can decide on your scale. What do we want for our scale? I think our scale here going up to 10 is pretty good for the y values. Let's get the y values going up to 10. If we want the y values to go up to 10 and we don't want to count 10, you can count by 2. Or if you do want to count 10, you can just have your coordinates look like this. However you want to set this up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like so. Just show me your scale. Or in this case, it's easier to, our scale is just 1, but it's easy to visualize if I show you where the 5 is. All right. Our asymptote is the x-axis. So let's write that down. Writing the asymptote, it's kind of hard to see this yellow. The x-axis, y equals 0. And let's start with our intercept. Our intercept is at 6. What other points do we know here? When x is equal to 1, y? It's not super clear. When x is equal to, oh, this was x equals 1. When x is equal to 2, the y value is positive 2. That's an easy point to put on the graph. Another easy point. Kind of hard to see the other ones. All right, and then go in the other direction. X equals a half is pretty close to 8. It's not exactly 8, but x equals negative a half is about 8. And now we're just going to start approximating. When x is equal to 1, about 3.4. 3.4 is around here. When x is equal to 3, we're a little over 1. And so on. In reality, if we wanted to do this exactly, right, our decay rate is 1.75. Every time x increases by 1, we get divided by 1.75. All right, but since this isn't a super nice number, it's kind of hard to do here. So this is our function, h of x. Now it also wants us to graph a reflection about the y-axis. So in red, let's reflect all of these points about the y-axis. You're going to get something that looks like this. Reflect every single one of these points about the y-axis. Then graph it again. This is the reflection. You could call this h of negative x. You could call it something else if you wanted. And as a side note, what is the formula for h of negative x? We replace x with negative x. We're going to have 6 times 1.75 to now positive x. And it wants us to give the y-intercept as well. So the y-intercept for both is 0, 6. That's what they're asking for in these problems. 214. 14. Oh, these ones. Match each function with one of the graphs. Specifically 2 times 1.28 to the x. So again, the y-intercept is 2. Some of the y-intercepts are 4, so we know we have to be looking at one of these. All right, so we're looking at one of these lower ones. What else do we know for number 14? It's growing. We have a positive b, b is bigger than 1. We're growing by about 28% with every increase of x. So it's a growth rate. So it's one of the bottoms, and it's one of them that's growing. So it has to be either E or F. Well, which one has a growth rate that's bigger or smaller? So we have to compare this now. Right? Compare this one down here with something else that's growing and starting at 2. 17 is also growing and starting at 2. Which one has a bigger growth rate? 17 does. So 14 is the one with the smaller growth rate. 14 is going to be F. The answer to number 14 is F. Lower starting value, it's exponential growth, and it's the smaller growth rate. And that's how you can approach these matching problems. Let's also do number 20. Which graph has the smallest value for B? Which graph has the smallest value for B? So if B is bigger than 1, then it's asking for the smallest growth rate, which would be F. But it doesn't tell us that, right? That's where this is a little tricky. If it's a decay, then B is going to be even smaller. Decaying is when B is less than 1. So we know the smallest B value is going to be one of the ones with decay. So either A, B, or C. Closer it is to 0, the faster the decay rate. The C. I think C. It's definitely not A. I think C is decaying faster than B. Yeah, because it's above it here, but then it meets it over here. So C is decaying the fastest. C is our answer for number 20. Look at number 30. Describe the end behavior. Well, let's graph it. 3 times 1/2 to the x minus 2. I forgot. 1/2 to the x minus 2. All right, this is exponential decay. Got an asymptote at y equals 2. Look at the end behavior. As x goes to the left, what's happening to our function value? As x goes to the left, the function value is going off, shooting to the moon. This is 30. We did the other ones elsewhere. As x is going towards the left, as x goes to negative infinity, the function value is going up to positive infinity. As x goes to the right, though, the y value is getting really close to that asymptote, negative 2. As x goes to the right, the function value approaches negative 2. And again, this was arrow notation. You could also write this with limit notation. As x goes to the left, function value approaches positive infinity. As x approaches positive infinity, the function value goes to -2. So either answer is good here. If you're going on to calculus, this is maybe a good habit to get into, but both are fine. Let's do the last one, number 46. What does that look like? Oh, I remember. Use a graphing calculator to approximate the solution of this equation. So we just graph both. -50, where is that? Well, I guarantee you we're gonna have to zoom out. -50 is, oh, negative is down. Woo, it's one of those days. And what's the other side of the equation? When is that equal? When is -50? We've graphed -50. When is that equal to -1/2 to the negative x? When is that equal to -1/2 to the negative x? Oops, I lost some parentheses here. Wait, did I typed this in wrong? The negative is on the outside, isn't it? I really screwed this up. When is that equal to -1/2 to the negative x? Oh, so this is how it works, right? The solution to this equation is when the left-hand side equals the right-hand side. Graphically, blue is the left-hand side, orange is the right-hand side. When are they equal? Right here. They're equal when x is 5.644, approximately, and y equals -50. The solution, when x is approximately equal to 5.644. That's how you approach these ones. And this is a really, really good strategy to be in because it gives you a visual conceptualization of what a solution to an equation means. Like very frequently, no, I'm not going to get into a rant right now. There's some cool stuff though. Anyway, good luck. Hope these questions helped. If anyone remembers back to 6.1, I said, hey, I'm going to go outside when I finish 6.2. I hope it's nice outside. I missed my window. You guys are more important than sunlight. Let me know if you have any questions and have a good day.